Show that the rectangle maximum perimeter that can be inscribed in the circle is a square.
Right, so we have three rectangles here, all with different perimeters. Now, which one would you think has the most perimeter? All these different sizes.
I would say the one in the middle. I would say this one.
See, I'm afraid you're incorrect. It's actually the square with the maximum perimeter, and that's what we're going to prove.
Oh.
So the dimensions of the thinner rectangle are 11 by 2.5. Therefore, the perimeter with 2x plus y would be 27. And the dimensions of the fatter rectangle are 9.5 by 6. Therefore, the perimeter would be 31. However, the dimensions of a square are 8 by 8, therefore giving it a perimeter of 32. So you can see from these three rectangles, the square is the one with the maximum perimeter.
Wait, so does this apply to all circles and all rectangles?
In fact, it does, and I'll show you the math to prove it. For the purpose of this explanation, we're going to use the unit circle. Therefore, we will use the equation x squared plus y squared equals r squared.
As you can see, the thin rectangle has a perimeter of 27, whereas a fatter rectangle would have a perimeter of 31, and the square would have a perimeter of 32, indicating that the square has the greatest perimeter out of all other rectangles.
This is the formula for the perimeter of a rectangle for x plus y relative to the unit circle. This equation, x squared plus y squared equals 1. Substituting the formula of a circle into the formula for the perimeter of a rectangle establishes limits for the rectangle's x and y values. Here we have the final product of substituting the y value into the perimeter of the rectangle's formula. Now, we found the derivative and then simplified as we could, multiplying the top and bottom of the 4 over 1 by root 1 minus x squared, making it one big fraction.
Now we solve for x, making it equal 0, and we end up with x equals 1 over root 2. Now we solve for y, plugging in the x values for the equation, and we end up with y equals 1 over root 2.
In conclusion, you can see the x and y values are equal, indicating that the sides of the rectangle are the same. Hence, it is a square that maximizes the perimeter for a rectangle inscribed in a circle.
Note, the radius for the equation can be any number. It won't change the fact that the maximum perimeter of the rectangle will be capitalized by square.